An electric arc, or arc discharge, is an electrical breakdown of a gas that produces an ongoing plasma discharge, resulting from a current through normally non-conductive media such as air. An arc discharge is characterized by a lower voltage than a glow discharge, and relies on thermionic emission of electrons from the electrode supporting the arc. An archaic term is voltaic arc, as used in the phrase voltaic arc lamp. History. The phenomenon was first described by Sir Humphry Davy, in an 1801 paper published in William Nicholson's Journal of Natural Philosophy, Chemistry and the Arts. In the same year Davy publicly demonstrated the effect, before the Royal Society, by transmitting an electric current through two touching carbon rods and then pulling them a short distance apart. The demonstration produced a feeble arc, not readily distinguished from a sustained spark, between charcoal points. The Society subscribed for a more powerful battery of 1,000 plates and in 1808 he demonstrated the large-scale arc. He is credited with naming the arc. He called it an arc because it assumes the shape of an upward bow when the distance between the electrodes is not small. This is due to the buoyant force on the hot gas. Independently, the phenomenon was subsequently rediscovered and described as a special fluid with electrical properties, by Vasily V. Petrov, a Russian scientist experimenting with a copper-zinc battery consisting of 4,200 discs. Overview. An electric arc is the form of electric discharge with the highest current density. The maximum current through an arc is limited only by the external circuit, not by the arc itself. The voltage across an arc decreases as the current increases, giving it a dynamic negative resistance characteristic. Where a sustained arc is required, this characteristic requires some external circuit element to stabilize current, which would otherwise increase bounded only by the supply limit. An arc between two electrodes can be initiated by ionization and glow discharge, as the current through the electrodes is increased. The breakdown voltage of the electrode gap is a function of the pressure and type of gas surrounding the electrodes. When an arc starts, its terminal voltage is much less than a glow discharge, and current is higher. An arc in gases near atmospheric pressure is characterized by visible light emission, high current density, and high temperature. An arc is distinguished from a glow discharge partly by the approximately equal effective temperatures of both electrons and positive ions. In a glow discharge, ions have much less thermal energy than the electrons. A drawn arc can be initiated by two electrodes initially in contact and drawn apart. This can initiate an arc without the high-voltage glow discharge. This is the way a welder starts to weld a joint, momentarily touching the welding electrode against the workpiece then withdrawing it till a stable arc is formed. Another example is separation of electrical contacts in switches, relays and circuit breakers. In high-energy circuits arc suppression may be required to prevent damage to contacts. Electrical resistance along the continuous electric arc creates heat, which ionizes more gas molecules, and as per this sequence, solid liquid gas plasma. The gas is gradually turned into a thermal plasma. A thermal plasma is in thermal equilibrium, which is to say that the temperature is relatively homogeneous throughout the heavy particles and electrons. This is so because when thermal plasmas are generated, electrical energy is given to electrons, which, due to their great mobility and large numbers, are able to disperse it rapidly and by elastic collision to the heavy particles. Current in the arc is sustained by thermionic emission and field emission of electrons at the cathode. The current may be concentrated in a very small hot spot on the cathode. Current densities on the order of 1 million amperes per square centimeter can be found. Unlike a glow discharge, an arc has little discernible structure, since the positive column is quite bright and extends nearly to the electrodes on both ends. The cathode fall and anode fall of a few volts occurs within a fraction of a millimeter of each electrode. The positive column has a lower potential gradient and may be absent in very short arcs. A low-frequency alternating current arc resembles a direct current arc. On each cycle, the arc is initiated by breakdown, and the electrodes interchange roles as anode and cathode as current reverses. As the frequency of the current increases, There is not enough time for all ionization to disperse on each half-cycle and the breakdown is no longer needed to sustain the arc. The voltage versus current characteristic becomes more nearly ohmic. The various shapes of electric arcs are emergent properties of nonlinear patterns of current and electric field. The arc occurs in the gas-filled space between two conductive electrodes and it results in a very high temperature, capable of melting or vaporizing most materials. An electric arc is a continuous discharge, while the similar electric spark discharge is momentary. An electric arc may occur either in direct current circuits or in alternating current circuits. In the latter case, the arc may restrike on each half-cycle of the current. An electric arc differs from a glow discharge in that the current density is quite high, and the voltage drop within the arc is low. At the cathode, the current density can be as high as 1 mA per square centimeter. An electric arc has a nonlinear relationship between current and voltage. Once the arc is established, increased current results in a lower voltage between the arc terminals. This negative resistance effect requires that some positive form of inductance an electrical ballast be placed in the circuit to maintain a stable arc. This property is the reason uncontrolled electrical arcs in apparatus become so destructive, since once initiated, an arc will draw more and more current from a fixed voltage supply until the apparatus is destroyed. Uses. Industrially, electric arcs are used for welding, plasma cutting, for electrical discharge machining, as an arc lamp in movie projectors and follow spots in stage lighting. Electric arc furnaces are used to produce steel and other substances. Calcium carbide is made in this way as it requires a large amount of energy to promote an endothermic reaction. Spark plugs are used in petrol internal combustion engines of vehicles to initiate the combustion of the fuel in a timed fashion. Spark gaps are also used in electric stove lighters. Carbon arc lights were the first electric lights. They were used for street lights in the 19th century and for specialized applications such as searchlights until World War II. Today, low-pressure electric arcs are used in many applications. For example, fluorescent tubes, mercury, sodium, and metal halide lamps are used for lighting. Xenon arc lamps are used for movie projectors. Formation of an intense electric arc, similar to a small-scale arc flash, is the foundation of exploding bridge wire detonators. Electric arcs have been studied for electric propulsion of spacecraft. Undesired arcing. Undesired or unintended electric arcing can have detrimental effects on electric power transmission, distribution systems and electronic equipment. Devices which may cause arcing include switches, circuit breakers, relay contacts, fuses and poor cable terminations. When an inductive circuit is switched off, the current cannot instantaneously jump to zero. A transient arc will be formed across the separating contacts. Switching devices susceptible to arcing are normally designed to contain and extinguish an arc, and snubber circuits can supply a path for transient currents, preventing arcing. If a circuit has enough current and voltage to sustain an arc formed outside of a switching device, the arc can cause damage to equipment such as melting of conductors, destruction of insulation, and fire. An arc flash describes an explosive electrical event that presents a hazard to people and equipment. Undesired arcing in electrical contacts of contactors, relays and switches can be reduced by devices such as contact arc suppressors and RC snubbers or through techniques including, immersion in transformer oil, dielectric gas or vacuum, arc chutes, magnetic blowouts. Arcing can also occur when a low-resistance channel forms between places with different potential. The conductive channel then can facilitate formation of an electric arc. The ionized air has high electrical conductivity approaching that of metals, and can conduct extremely high currents, causing a short circuit and tripping protective devices. Similar situation may occur when a light bulb burns out and the fragments of the filament pull an electric arc between the leads inside the bulb, leading to overcurrent that trips the breakers. Electric arc over the surface of plastics causes their degradation. A conductive carbon-rich track tends to form in the arc path, negatively influencing their insulation properties. The arc susceptibility is tested according to ASTM D495. bipoint electrodes and continuous and intermittent arcs. It is measured in seconds to form a track that is conductive under high voltage low current conditions. Some materials are less susceptible to degradation than others. For example, polytetrafluoroethylene has arc resistance of about 200 seconds. From thermosetting plastics, orchids and melamine resins are better than phenolic resins. Polyethylenes have arc resistance of about 150 seconds, polystyrenes and polyvinyl chlorides have relatively low resistance of about 70 seconds. Plastics can be formulated to emit gases with arc-extinguishing properties. These are known as arc-extinguishing plastics. Arcing over some types of printed circuit boards, possibly due to cracks of the traces or the failure of a solder, renders the affected insulating layer conductive as the dielectric is combusted due to the high temperatures involved. This conductivity prolongs the arcing due to cascading failure of the surface. Arc suppression. Arc suppression is a method of attempting to reduce or eliminate the electrical arc. There are several possible areas of use of arc suppression methods, among them metal film deposition and sputtering, arc flash protection, electrostatic processes where electrical arcs are not desired, and contact current arc suppression. In industrial, military and consumer electronic design, the latter method generally applies to devices such as electromechanical power switches, relays and contactors. In this context, arc suppression refers to the concept of contact protection. Part of the energy of an electrical arc forms new chemical compounds from the air surrounding the arc. These include oxides of nitrogen, and ozone, which can be detected by its distinctive sharp smell. These chemicals can be produced by high-power contacts in relays and motor commutators, and are corrosive to nearby metal surfaces. Arcing also erodes the surfaces of the contacts, wearing them down and creating high contact resistance when closed. See also, arc transmitter, Marx generator, spark gap, vacuum arc. References. External links, high voltage arcs and sparks videos of 230 kV three-phase Jacobs ladder, and unintentional 500 kV power arc, high voltage arcade gap calculator to calculate the length of an arc knowing the voltage or vice versa, a VKISA 1/4 La copyright S electric arc between two carbon rods. Video on the portal FizeKip, unusual arcing photos.